Good morning, everyone. A very good morning. Shall we begin the session? Today's topic is database design process, and this is the last topic, or begins the last class for this database design concepts revision. In the tomorrow's class, I will start with a new module that may be a employability and professional development. So, any doubts, any clarification regarding this module, you can finish this. Yeah, you can finish the doubts within today's class only, or maybe the tomorrow's class. That's not an issue, but try to resolve try to resolve each and every concept, each and every doubt in today's class. Shall we begin? Or you should, okay, take the 5 minutes for any doubts. Alright. So far we have looked about the various issues about the normal forms normalizations, that is first NF, 2NF, 3NF, 4NF, BCNF. So we have looked about these issues. Now in this section we have studied about how normalization fits into the overall database design process, or how normalization works for the database design process. So earlier in this chapter we have started with the concept with the relation R that is given and proceed to normalize it. And there are several ways in which we have come up with the schema RR that have been generated in converting an ER diagram to a set of the relation schema. Whatever the schema we have considered, whatever the diagram we have considered over here. So in this, we are going to study about a single relation schema containing all the attributes that are of the interest. And normalization process then breaks up into the smaller schema, that is into the smaller parts, into smaller categories of the normalization. That may be a 1NF, 2NF, 3NF, or BCNF. Then RR could have been a result of the ad hoc design of relation that we then test to certify or verify that it satisfies the desired normal form and that provides the implications of these approaches. Now we also examine some practical issues in the database design, including the denormalization for performance and the examples of the bad design that are not detected by the normalization. So let's start with the ER model and normalization. So when we define an ER diagram carefully that identifies all the entities correctly and the relation schema generated from the ER diagrams, that should not need much further normalizations. However, there can be a functional dependencies between attributes of an entity. For instance, suppose an instructor entity set have attributes department name, department address, and there is a functional dependency department name, department address. So I would then need to normalize the relation generated from the instructor. Now, such dependencies arises out of the poor ER diagram design, and if we have designed the ER diagram correctly, we will created a department entity set with attribute department address and a relationship set between the instructor and the department. Similarly, a relationship set involving more than one entity sets may also result in a schema that may be or may not be a desired normal form. Now, since most of the relationship sets are binary, such cases are also relatively very rare. And in fact, some ER diagrams also variant actually makes it difficult or impossible to specify what are the binary form, what are the non-binary relationship set, why it is developed, what are the various drawbacks or fruitfulness of these relationship sets. These functional dependencies can also help us to detect the poor ER design, and if the generated relation schemas are not in the desired normal form, the problem can be fixed in the ER diagram. That is, a normalization can be done formally as a part of the data model. And alternatively, normalization can be left to the designer intuition during the ER modeling that can be done formally on the relation schema that is generated from the ER diagram or ER model. Now next is how to view or how to illustrate a need for the, or what is the need for the multi-value dependencies and the fourth normal form. That begins with the derived from our ER design. So instead of processing, or indeed the process of creating an ER design tends to generate the 4NF design also. And if a multi-value dependency holds and is not implied by the corresponding functional dependency, that always or that usually arises from one of the following sources. One is a many-to-many relationship set, Next is multi-valued attributes of an entity set. And for many-to-many relationship set, each related entity set has its own schema, has its own attribute, own value, and there is an additional schema for the relationship set. And for a multi-valued attribute, a separate schema is created consisting of that attributes and the primary key of the entity set. Whatever the primary key, whatever the attribute, whatever the schema that is covered, that also includes of the primary key of the entity sets, as in the case of the phone number attributes of the entity set instructor. And the universal relation approach to relational database design starts with an assumption that there is only one single relation schema containing all the attributes of the interest. That also defines how the users and the applications interact with the database. How they interact with the database, what are the various attributes, what are the various relationships that also assumes in the database. So a desirable feature of a database design is a unique role assumption. That means each attribute name have a unique or has a unique meaning in the database. This prevents us from using the same attribute to mean different things in different schemas. Different schemas, different attribute, different material. For example, we might otherwise consider using the attribute number for phone number in the instructor schema and room number in the classroom schema. And that also join for a relation on the schema instructor with one on classroom that is a meaningless. And that can also work carefully to ensure you use the right number in each circumstance. That may be a room number, that may be a phone number, that having a different attribute, having a different attribute name for the phone number, and for room number that serves to reduce the user errors. While it is better to use the incompatible attribute in the string, the attributes of a relation have the same meaning, same attributes. It may be a good idea to use the same attribute name. For this reason, we use the same attribute name for both the instructor and the student entity. And if this was not the case, then we wish to generate or generalize these entity sets by creating a person entity set. We would have to rename the attributes. Even if we do not or did not currently use to have a generalization of the student and the instructor. So if we foresee such a possibility, that is better to use the same name in both entity sets. That may be a relation, that may be a schema, that may be a student and the instructor. Although technically the order of the attribute names in the schema does not matter, it is convention to list primary key attribute first. This makes reading default output that is very easy. And in the last database schemas also, relationship sets are often named via concatenation of the names or named of the related entity sets. Perhaps it is also used with intervening hyphen and the underscore. So we have reused a few such names, for example, instructor section, student section. So we use the name teaches and takes instead of using the longer concatenated names. This is very much acceptable since it is not hard to you to remember the associated entities and for a few relationships. Next part is pre-normalization for performance. So if there is any file, any relation that is not normalized up to the information or up to the performance, so it is pre-normalized for the performance. So occasionally database designer choose a schema that has a redundant information that is not normalized. So there are multiple cases, there are redundancy that also supports the redundant information that is not normalized. So they use the redundancy to improve the performance for specific application. So the penalty paid for not using a normalized schema is the extra work. Extra work means doing the extra work in terms of the coding time, in terms of the execution time, to keep the redundant data existent. So for example, Suppose all the course prerequisites have a display along with the course information every time that then a course is accessed. So in a normalized schema, this requires a join of the course with the prerequisite. One alternative to computing the join on the fly is to store a relation containing all the attributes of the course and the prerequisite. So this makes displaying the full course information faster. However, this information for a course is repeated for every course prerequisite and all the copies must be updated by the application whenever a course prerequisite is added or dropped. So the process of taking a normalized schema and making it non-normalized is known as a denormalization. And designers use it to tune performance of system to support the time-critical operation that is very much supported by the database system today that is used to normalize schema. Additionally, stores the join of the course and the prerequisite as a materialized view. Recall that a materialized view is a view whose result is stored in the database and must be both up to date when the relation used in the view are updated. So whenever it is updated with the result, whenever it is updated with the storage, so this normalization is using with the materialized view that does not have a spaces and the time overhead. However, it has the advantage that keeping the view up to date is a job of the database system. Whatever the job that is required, that is also the case of the database system, not the application programmer. Now, there are some other aspects of also of the database design that are not addressed by the normalization that lead to the database design or the bad database design. This will lead to the database performance. This will lead to the database design. And whatever the data that is pertaining to the time or to the ranges of the time or several such issues. So we will give the examples over here. Obviously, such design should be avoided. So consider an university database where we want to store the total number of the instructors in each department in different years. So a relation that is the total instructors, department name, year size could be used to store the desired information. And the only functional dependency on this relation is the department name, year, size, and the relation is in BCM. And there is an alternative design that is used to use multiple relations is storing the size information for a different year. So let us say the year of the interest are the 2007, 8 and 2009. So we will then use the relations of the form total instructor department 2007, 8, 9, all of which are on the schema department name and the size. And the only functional dependency here on this relation will be the department name and the size. So these relations are also in the BCA. And yet another example, another way of representing the same data to have a single relation last year, department year, that is a department name, total instructor 2007, 8, 9. So the only functional dependencies are from department name to the other attributes, and again the relation is in BCN, that is a boycott normal form. And these representations are those in the department year relation with one column for each value of an attribute that are known as the cross tabs. And they are widely used in the spreadsheet and reports and in the data analysis too. Such representations are useful for display to the users for the reason just given that is not desirable in the database design. The next is modeling the temporal data. How to model the temporal data? Temporal means the temporary data that is available with the ID, street number, street, city. Now next is application design and development that also includes the interfaces, that is the mainframe era. This is a personal computer era, this is the web era. Mainframe contains mainframe computer, that is a proprietary network or the dial-up phone connections. Then person means LAN, that is the local area network, includes the application program, the desktop IC, PCs. Then there is a web application server, web browsers, databases that authenticate itself by the username and the password. And the application then uses your identity to extract the information such as your name and the courses for which you have registered. And from the database and display the information. And whatever application that provides a number of interfaces that lets you register for the courses and query with a variety of the other information such as the course and the instructor information. So such applications include to automate a variety of the tasks such as the sales, purchases, accounting, payroll, human resource management, inventory management, among many others. So these application programs may be used even when it is not apparent, it is not used. For example, a new site may provide a page that is transparently customized to different users or individual users, even if the user does not explicitly fill any form when interacting with the site. So to do so, it actually runs an application program that generates a customized page for each user, customized that based on the history of the article that is browsed by the users. So browser uses standardized syntax or language that is known as the HTML, hypertext markup language, that supports both formatted display as well as unformatted display. That may also be the case of the operating system, that is an independent procedure, that is one of the part of the browser, and much pretty with any other computer, very much easy. All computers today have a web browser installed. Therefore, a web application or web-based application can be accessed from any computer that is connected to the internet. Now, there are two approaches. One is client-server approach, one is a peer-to-peer approach. In client-server, there is one server and multiple clients. And server is connected to the client, so server provides the services to the clients, and clients provide the take the request from the or take the services from the client by fulfilling the request. So HTML is hypertext markup language, that is a language application program that provides the backend, including the Java servlets, Java server pages, DSP, ASP, scripting languages such as PHP, Perl, or the Python. So in this we describe how to build such applications, starting with the web technologies and tools for building web interfaces, technologies that covering the application architecture, performance, security issues in building the application. There are some fundamentals of the web. First is a URL, that is a globally unique name for each document that can be accessed on a web. Example is this is http www.acm.org signal. This HTTP is hypertext transfer protocol that indicates with the following tabs. So this is a protocol for transferring the HTML document. Then second part is the name of the machine that has a web server. And rest of the URL is the path name of the file on a machine or other identifier, unique identifier of a document within the machine. Then this is a language, hypertext markup language. This is a hypertext markup language that provides a table representing in the HTML format that displays the image generated by the browser from the HTML representation. This source also shows a few of the HTML tags, and each tag, each page should be enclosed within an HTML tag, while the body of the page is enclosed in a body tag. A table is also specified with a table tag that contains rows specified by the TR tag and the header row TH tag, while regular are the rows have a table cell, that is the TD tag. This is another example of the HTML form. It starts with the HTML within the right angle bracket and the left angle bracket. Then body, then form action equals to %query, method equals to get. Then search for, select name equals to %type. So we are getting the name as a %type. There are two values in this. One is the student, that is by default it is selected because it is given option value equals student, then selected the student. Then value equals to instructor option. Then select will be clause. So this is one part of the select clause. This is the select clause. Then BR break, the name, input type equals to text, size equals to 20, name equals to name. Then type equals to submit, value equals to button. So it takes two fields. One is a name, one is a button. Then form is closed, body is closed, and HTML is closed. So this provides the cells with the TT tag, this provides the cells with the TH tag. To specify how it is formed for this. So this is the output of this. Search for, When a user click on this, there is an instructor and the student, then name, then submit. So when we talk about a web server, that is a program running on a server machine which accepts a request from a web browser and syntax in the form of HTML document. So this is the server that is same as the clients. As a result, web server connects as an intermediary to provide access to a variety of the information services. So there is a CGI standard, Common Gateway Interface standard, that defines how the web server communicates with the application program. And the application program typically communicates with the database server through ODBC, Open Database Connectivity, JDBC, Java Database Connectivity, or other protocols in order to get or store the information. This is the browser. This is a network, this is the HTTP, this is the server that includes the web server, application server, database server, and the data. So this is three-layer web application